So, are you ready, my dear friends? So, now we are going to learn about and explore the instruments. Yes, the instruments, the very basic and first category that we have seen a while ago. Okay, so let's start with the galvanometer. What is a galvanometer? Let's make a galvanometer ourselves, and that will going to help us understand that what is the galvanometer itself. Well, let's make it precisely. This is north side of a bar magnet, and this is south side of a bar magnet. Well, you can assume it like a little U-shape type, or just simply the bar magnet will also be okay. That's all about the precision and nothing much about that. Okay, now on the center we have our spindle. Well, you can call it soft iron core if not spindle. So this is soft iron core, and you have to attach a dial with it that will going to show us a number. So to see the numbers ourselves we need the scale also. So this is called going to be our scale, on which we will have the measurements, and that measurements will going to help us understand that what's going on. Okay, so let's begin with that. Finally, the final thing, which is coiling up it. So we have to coil it up with our copper wire. Okay, so believe it or not, but this is precisely and exactly our galvanometer. Well, let me mark the thing so that you can see the things more clearly. This is the dial. These are the copper wire. This is the bar magnet, as we all know, obviously. So bar magnet this side, bar magnet this side. Well, you can also imagine or take any north or south like thing, and I will answer one of your question if you have. Let's see that if you have that question in a moment. And this is finally gonna call as a scale on which we see the numbers. Okay, so how galvanometer actually works? Let me label that, title it up, galvanometer. So, first of all, what is the galvanometer? We have made a meter, but and we are calling it galvanometer, but what is the galvanometer itself? Well, the precise meaning of the galvanometer is it is current sensitive device. Current sensitive device. Wherever there is current, it will going to deflect from its meter, and that's what we are going to see. Well, I said it's an instrument, but I'm writing device. Don't get confused. The words are pretty much each other's complement, so we write it down. Just you can also call it as a small kind of machine that's working, but precisely this is an instrument itself because it is telling us about the scale, about the numbers. Okay, so what actually happens? Imagine that you have a galvanometer. I'm making it a small one so that you can understand the entire story. And there is a wire in which the current is going up. So the galvanometer starts deflecting. Initially, the galvanometer is here and it deflects to this point. So this deflection is because of the current, and imagine with the same scenario, if the current is going downward, the galvanometer might deflect in this direction, and its deflection changes from 0 to this point. It means galvanometer is a current sensitive device. And how this device is actually working, if you look closely, so there are the magnets, permanent magnets that we do have here, and that permanent magnets having the effect which is going from north to south like this. These are the invisible magnetic waves that we are not able to see as usual, but we can imagine that it's going continuously, and when it's going continuously the dial is at the zero position. Now what with that, and how we are going to see the next one? Well, the thing is actually, when a current is passing through a wire, it is also producing the magnetic effect, and that magnetic effect charges this soft iron core and converts it into a solenoid. Well, what is a solenoid? If you do not know that, in simple words, solenoid is a temporary bar magnet. It is a temporary bar magnet. So that temporary bar magnet occurs on any soft iron core. If you coil it up and the current passes through that soft iron core, that becomes a magnet for a while, maybe for 15 minutes or 20 minutes or 30 minutes, as much as time the current is going through it. That depends. So with that effect, if it gets north, you can assume that it will going to deflect in this direction, and if the wave is south in nature and the deflection is south instead, it will going to get attracted towards, in this case, because this is north and this is south, so south and south repels each other and north and south attract each other. This is the simple principle of the galvanometer that changed the entire era of devices and instruments. We can make from the galvanometer our ammeter, which can measure the current passing through the wire itself. We can make a voltmeter. We can make a tons and tons of instrument by the simple principle of attraction and repulsion of magnets and temporary magnets, and we can scale it up, use the scale, measure that, and it's working very well. I hope you have understood the concept of the galvanometer entirely now. You can make a galvanometer by yourself too, but why to make a galvanometer when we have other options that we are going to see in the next one. So see ya, take care, and we are going to see the next one in the same video, but for me it's the end of the galvanometer and we are going to start the voltmeter in the next one. So take care, God bless.